All right, going to be working here 8.3, which is the section on trigonometric equations. Number 11, I'm not going to do, but I'll start on number 13. So on number 13, it's asking us to find all of the solutions to a trigonometric equation on an interval 0 to 2 pi. Come on, let's go. This board is dirty. That should be good. Now, do the markers work? All right, so 2 sine theta plus 3 equals 2. 2 sine theta plus 3 equals 2. And we're looking on the interval 0 to 2 pi, not including 2 pi. So what we'll do here is try and isolate sine theta. So 2 sine theta. And subtract 3 from both sides, which gives me -1. I'll divide both sides by 2. So I want to know where sine of theta is -1/2. That means I need the argument of the function, which is theta, to correspond to the y coordinate on the unit circle with a value of -1/2. Y value is up and down, so we're going to be looking at this angle here and this angle here. This angle here is -pi/6. You could also say that's 11 pi/6, but I went backwards. And then this one right here, this angle is 7 pi/6. So to generate the solutions between 0 and 2 pi, I'm actually just looking between 0 and one revolution, one regular revolution, which is counterclockwise. So I actually cannot use -pi/6 here. I needed to go around to here, so I'm going to change this to 11 pi/6. Now, these should be my two solutions. Just to be thorough here, let's act like this wasn't given to us. My general solutions would be, I could use this for 11 pi/6, and then I'd have to come all the way back around. So I would have plus 2 pi n, that would be a full revolution. Over here I take 7 pi/6 and go plus 2 pi n. Again, to get back around here, I'd have to go one full revolution. Since these aren't directly across from each other, that's what I'd have to do. Then I could get a common denominator here, 11 pi/6 plus, this would be 12 pi n over 6. Put them together, 11 pi plus 12 pi n over 6. That would be my general solution. And then over here, get a common denominator. If we do that, we would have 7 pi plus 12 pi n over 6. And then we could cycle through different values of n being 0, 1, 2, 3, 4, until we were outside that interval. Or we could do n equals -1, -2, -3, and make sure we stay within this interval. All right, let's move on. 7 pi/6 and 11 pi/6 were the solutions to that equation on that interval. Okay, number 15. 2 sine theta plus 1 equals 0. Well, this can be pretty boring because we're going to get this same exact equation. When we subtract 1 on both sides and divide by 2, we get sine is -1/2. And that's the same exact thing we just had, so we're going to have the exact same solutions. Okay, next one is number 19. We have 4 secant theta plus 6 equals -2. 4 secant theta plus 6 equals -2. And keep in mind, we're still on that same interval, 0 to 2 pi. So I'm going to isolate the secant theta, and that means I'm going to subtract 6 on both sides. So I get negative 8 when I subtract 6. Divide by 4, secant theta is negative 2. Now secant is the same as 1 over cosine. So we're saying, where is 1 over cosine equal negative 2? I can multiply both sides by cosine of theta, and then I can divide both sides by 2, negative 2, sorry. So this is saying, where on the unit circle is my x-coordinate? Negative 1/2. And that's going to happen here and here. And since we're only looking between 0 and 2 pi, this angle right here is 2 pi over 3. And then this one right here is, let's see, if we count it by pi over 6, it's just to practice this again. You got pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces to be 4 pi over 3. So 4 pi over 3. And those are the only two solutions within 0 to 2 pi. So that's it. And then again, if we wanted general solutions, take this, add a full rotation, so plus 2 pi n. Here, add a full rotation, plus 2 pi n. Common denominator, all that stuff. All right, let's move on. 21. Three root 2 cosine theta plus 2 equals negative 1. Okay, I'm going to divide or subtract 2 on both sides. That's going to give me a negative 3 over here. I'm going to divide both sides by 3 root 2. So cosine theta equals negative 3 over 3 root 2. 3's cancel. I get cosine theta equals negative 1 over root 2. And so we're saying, where on the unit circle is our x-coordinate negative 1 over root 2? We don't recognize that as one of our common values unless we rationalize. Multiply top and bottom by root 2. So we get negative root 2 over 2 if we multiply top and bottom by root 2. That's more familiar. X-coordinate, we want to know where the x-coordinate is this. So that's going to happen here and here. And between 0 and 2 pi, that's happening at 3 pi over 4. And this one is 5 pi over 4. Those are our only solutions between 0 and 2 pi. Again, general solution, plus 2 pi n, plus 2 pi n, because they're not directly across from one another, you'd have to go all the way around. So that's it for that. Okay. 25. Making sure I'm not missing any. 2 sine squared theta minus 1 equals 0. 2 sine squared theta minus 1 equals 0. I'm going to isolate the sine squared. 2 sine squared theta equals 1. It's adding 1 to both sides. I'm going to divide by 2. And I'm getting a phone call. It's probably Yep, that was junk. All right. Be careful here. It says sine squared theta equals 1/2. It's not saying sine theta is 1/2. So I need to take the square root. When I take the square root, I have to do plus or minus square root of 1 over 2. Now this is the same as square root of 1 over square root of 2. This is the same as, well, square root of 1 is just 1, and root 2 is root 2. Multiply top and bottom by root 2, and you get plus or minus root 2 over 2. That's one of our common values on our unit circle. Sine is the y-coordinate. It's saying, where is the y-coordinate? Positive root 2 over 2. That would happen here and here. And also, where is it negative root 2 over 2, which would happen here and here. So it's at these like 4 corners. Notice that each of these is you just have to turn by 90 degrees to get back and forth. Now, 90 degrees are pi over 2. So start here, pi over 2, add another pi over 2, add another pi over 2, add another pi over 2, and you can start walking through these. So I could start here, pi over 4, and then I could write a general solution, pi over 4 plus pi over 2n times n. And that would be a general solution. I could let n be 0, 1, 2, 3, and start getting them all. That's my general solution. They just want the answers between 0 and 2 pi, so I can just 3 pi over 4, this one is 5 pi over 4, this one is 7 pi over 4. So those are the 4 answers, but that's the general solution, using pi over 2 to move around. 29. Cosine 2 theta is negative 1/2. Okay, so the big difference here is that notice our argument is 2 theta as opposed to just theta. So here's where the general solutions come into play. Even though I'm only looking between 0 and 2 pi, I know right now that my argument, right, that angle has to correspond to an x-coordinate of negative 1/2, which was here and here. Now this answer we just did a little while ago was 2 pi over 3. And then 4 pi over 3 was this one. And now we need general solutions. So what I need is for my argument, 2 theta, to be equal to 2 pi over 3 plus 2 pi n. That would get me back around. And then I also need, I'll do it right here, 2 theta to be equal to 4 pi over 3 plus 2 pi n. Now we'll solve for theta. So I'll divide both sides by 2. We get theta equals, let's see, pi over 3 plus pi n. Dividing each of those by 2. Here we're going to get theta is, divide 4 by 2, we still have 2 pi over 3 plus pi n. I'm going to go ahead and get common denominators on these now. So I have to multiply top and bottom by 3. So we get theta is pi plus 3 pi n over 3. Here I'm going to have 2 pi plus 3 pi n over 3. Okay, now let's go ahead and start plugging in values of n. If n is 0, I get just pi over 3. But I also get over here 2 pi over 3. And those two numbers, remember we're trying to stay between 0 and 2 pi. Those two values are still smaller than 2 pi. So I can keep going. If n is 1, so if n is 1 here, we get 3 pi plus pi is 4 pi over 3. And if I let n be 1 here, I get 2 pi plus 3 pi is 5 pi over 3. And 4 over 3 is still less than 2, so that works. 5 over 3 is still less than 2, right? I'm comparing that coefficient. And so all those work, all those work. Let's let n be 2. If n is 2 in here, we get 6 pi and then plus a pi, that's 7 pi over 3. And if I let n be 2 here, we get 6 plus 2 pi, it's 8 pi over 3. 7 over 3 is bigger than 2, 8 over 3 is bigger than 2, so I'm going to stop. Now I'm not going to use negative n's, because if I put a negative right here, negative 1, I'm going to get pi minus 3 pi, it's negative 2 pi. That's no good because I have to stay positive only. So there's no need to check on the negatives. So it's these 4 solutions. Just see here, which one was this? Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay, now we have 31. Ooh, this one's interesting. 31. Secant of 3 theta over 2 equals negative 2. So secant is 1 over cosine. So this is 1 over cosine of 3 theta over 2 equals negative 2. Multiply both sides by that cosine thing, you get 1 equals negative 2 cosine of 3 theta over 2. Divide both sides by negative 2, you'll get cosine of 3 theta over 2 equals negative 1/2. So here we're saying, where's our x-coordinate negative 1/2, which happens here and here. This is 2 pi over 3. This is 4 pi over 3. But we need our argument to be equal to one of those. So I need that 3 theta over 2 equals 2 pi over 3. That's this angle. But we can go around all the way back to it. So plus 2 pi n. And then the other thing we need is that 3 theta over 2 equals this one, 4 pi over 3, plus full rotations to get back to it. And now I just need to try and clean up and get theta by itself. So I multiply both sides by 2 and divide by 3. So theta will be, if I multiply both sides by 2, I get 4 and 4 here. Divide by 3, I'm going to get 9 here and 3 here. So I'm going to get 4 pi over 9 plus 4 pi n over 3. Get a common denominator between these, so multiply 3 on top and bottom here. So theta is 4 pi over n plus, when I multiply top by 3 there, I get 12 pi n over 9. Let me put those together. Plus all over 9. There we go. So that's one of my general solutions. This one, same thing. Theta is, multiply both sides by 2. I get 8 pi. Up top, I get 4 pi n. Divide both sides by 3. Get 9 here. I get 3 here. Plus. Now common denominator, so 3 on top and bottom here. I get 8 pi plus 12 pi n over 9. That's my second general solution. And now start plugging in values of n and see if we can get all the answers between 0 and 2 pi. So if n is 0, we get just 4 pi over 9. And then if I go n is 0 here, I get 8 pi over 9. Those are both less than 2 pi, so I move on. If I plug in 1 here, I get 1 here, I get 12, and then 4, that's 16 pi over 9. 16 divided by 9 is still less than 2, so I'm good. Here, if I plug in 1, I get 20 pi over 9. 20 divided by 9 is bigger than 2, so that's no good. Now, I should just check n is 2 on this one, just to make sure. N is 2. 2 here, 24 plus 4. No, that's not going to work. It's too big. I don't need to check negatives because I don't have any negative. 0, 2 pi, I don't have negative answers. So it looks like just these 3 right here. We got 4 pi over 9, 8 pi over 9, 16 pi over 9. That was kind of cool. Where are we at? Where are we at? 33. Switch markers here. Cosine 2 theta minus pi over 2. Cosine 2 theta minus pi over 2 equals negative 1. All right, well, we want to know when cosine of something is equal to negative 1. That's the x-coordinate. So cosine, the x-coordinate is negative 1. That only happens here. And that's at pi, right? So that's pi. So this general solution would look like pi. Plus 2 pi n would get you back there, right? So full rotations get you back there. We need the argument, which is 2 theta minus pi over 2, to be equal to this. All right, that's a little different, but I'm just going to add pi over 2 to both sides. I'm going to go ahead and put the pi over 2 right there, add it. The reason I put it there is because I'm going to put these two together with a common denominator. So 2 on top, 2 on bottom. Add those together, I get 3 pi over 2 plus 2 pi n equals 2 theta. And then divide both sides by 2. So theta equals 3 pi over 4 plus, divide that by 2, I just get pi n. Get a common denominator, so multiply top and bottom here by 4. That's really a 1 down there. So I get 3 pi. I multiply that by 4, so plus 4 pi n over my common denominator of 4. That's my only general solution, and now I start cycling through values of n. So if n is 0, I get 3 pi over 4. So if n is 0, I get 3 pi over 4. If n is 1, I get 7 pi over 4. If n is 2, I get 8, 9, 10, 11 pi over 4. And this one got bigger than 2 pi right there. 11 over 4 is bigger than 2. 7 over 4 was fine. So it looks like just these two answers. Those are the only ones. Which one was this, 39? No, wait. This was not number 39. I apologize. This was 33. 33. Now, I haven't really shown you this, but you might be asking yourself, like, if you're losing track of what's going on here. Like, you're like, wait a minute, hold on. We said that the answer was pi plus 2 pi n. No, we're saying the argument has to be equal to this. And these are the two values that will give us this angle if we plug it in, and those are the only ones between 0 and 2 pi. So let me give you, just illustrate this. If I plug that in, cosine 2, now theta I'm going to replace with 3 pi over 4, then minus pi over 2, I should get negative 1. So let's see, this, that's a 2, so you get cosine, it's a 3 pi on top, I still have a 2 on the bottom, minus pi over 2. Those have the same denominator, so subtract them. 3 pi over 2 minus pi over 2 is 2 pi over 2. And the 2's cancel, you just get cosine of pi. Cosine of pi is negative 1, checks. So this is only used to build up the solutions, right? But setting the argument equal to the general solution here will allow you to create your list. $35. Tangent of theta over 2 plus pi over 3 equals 1. Okay, so we have tangent of something is 1. The only places that tangent is 1 on the unit circle is here and here. They're directly across from each other. That's at pi over 4 and at 5 pi over 4. So my general answer here, I could say pi over 4 plus pi n. Since it's directly across, I can just jump by pi to get back and forth. So that's my general solution. I need my argument to be equal to that. So I need theta over 2 plus pi over 3 to be equal to pi over 4 plus pi n. All right, I'm going to subtract pi over 3 first. So pi over 2 equals pi over 4 minus pi over 3 plus pi n. We're not doing anything with this because it has an n in it, so I can only combine those two. Getting a common denominator here of 12, multiply top by 3 here, top by 4 here, you wind up with negative pi over 12 as your new fraction, and then plus pi n. And now I multiply both sides by 2 to get rid of that division by 2 on the left side. So theta is, when I hit this with the 2, it becomes negative 2 pi over 12, and that reduces to be negative pi over 6. Hit that with a 2, and I get just 2 pi n. I need a common denominator, so there's a 1 down there. I multiply top and bottom of this by 6. So negative pi plus 12 pi n over 6, my common denominator. So there's my general. I'm going to start plugging in values of n. So what happens if n is 1? So if n is 0, sorry. If n is 0, I just get negative pi over 6. Right? And I throw that out because that's not within 0 pi, 0 to pi, so I throw it out. If n is 1, I get, let's see, negative pi plus 12 pi. It's 11 pi over 6. That does work. If n is 2, 24 pi minus a pi, it's 23 pi over 6. That's outside of 2 pi. So I only have one answer, 11 pi over 6. $39, $37, $37, $37. Sine theta is a half. Okay, now they want general solutions. All right, general solutions. So now this is going to be easier because we've already done this. Sine is 1/2, means where is your y coordinate 1/2? That happens here, happens here. This is pi over 6. This is 5 pi over 6. So to get all the answers, you just add 2 pi into this one, add 2 pi into this one, and we're in business. I will get a common denominator, hit top and bottom of that with 6. So plus 12 pi n over 6, and then here, top and bottom here with 6, 5 pi plus 12 pi n over 6 again. There we go. These are our general forms. 39, tangent theta is negative root 3 over 3. Tangent theta is negative root 3 over 3. This one's a little tricky. So you're trying to figure out where tangent is negative root 3 over 3. Okay, so let's start ruling some things out. All right, we can't be here because tangent's positive there. We can't be here because tangent's positive there. We cannot be at the 45s because there the x and y coordinates are the same but off by a sign. So we would get -1 there, -1 there. But what about this one right here at 2 pi over 3? Let's see, 2 pi over 3. What would happen here? Our x coordinate is -1/2. Our y coordinate is root 3 over 2. Tangent is this divided by this, y divided by x. So if I take root 3 over 2 and I divide it by -1/2, I would reciprocate, so flip, and it would become -2 over 1 here. The 2's would cancel, you get negative root 3. That's not what we have here. We have negative root 3 over 3, so it's not that, which means it's got to be this one. This one right here is 5 pi over 6, and at 5 pi over 6, my x coordinate is negative root 3 over 2. My y coordinate is 1/2. So if we do this fraction the other way around, you'll see it's going to work. We're going to get the y coordinate over the x, reciprocate, 2's cancel, you get -1 over root 3. Now rationalize, top root 3, bottom root 3, you get negative root 3 over 3. So that's the one. It's this one right here. Now, it's not just that one, okay? You also have to look in this quadrant. Directly across from that over here, you have root 3 over 2 and -1/2. And if we do the ratio, this over this, it's the same thing as this, except the negative is up here instead, but it's still going to carry through and have a negative on the outside. So it's those two angles. But we, for a general solution, can just take the 5 pi over 6 and add a pi n to just go like a half rotation, half rotation, half rotation, half rotation, and we're back and get all the answers. So this is it, 5 pi over 6 plus pi n. I like that one. All right, 41. Cosine theta is 0. Okay, I'm not sure why they're giving you this one. This one's pretty basic here. That means when's the x-coordinate 0? It happens here and here. That angle's pi over 2. This angle's 3 pi over 2, but it doesn't matter. Because if I just add half rotations to this, I get them all. So pi over 2 plus pi n. Let's get a common. So I just multiplied 2 on top here, 2 on the bottom here, put them together. And remember, you cannot put these two together, right? You just leave them apart. So that's our general. All right, cosine 2 theta is negative 1/2. Number 43. Cosine 2 theta, negative 1/2. So where is the x-coordinate negative 1/2? Here and here, they are not directly across from each other, 2 pi over 3, and this one is 4 pi over 3. So to get them all, you have to add full rotations. But this is not our final answer because our argument here is not just theta, it's 2 theta. So I need 2 theta to be equal to this. And I need 2 theta to be equal to this one, 4 pi over 3 plus 2 pi n. All right, divide both sides by 2. Theta is pi over 3 plus pi n. Over here, divide both sides by 2, you get 2 pi over 3 plus pi n. We could get a common denominator on these, or not, but I'm going to do it. I had multiplied 3 on top and bottom here, so pi plus 3 pi n over 3. Over here, again, multiply top and bottom by 3 here. So 2 pi plus 3 pi n over 3. So those are our general solutions. 45. Sine of theta over 2 equals negative root 3 over 2. So that's saying where is our y-coordinate negative root 3 over 2? Looking off our unit circle, y-coordinate negative root 3 over 2, that's here and here. All right, so this is 8 pi over 6, 4 pi over 3 there, so 4 pi over 3. And then, I'm sorry, 10 pi over 6, this is 5 pi over 3 there. So that's this one. At both those angles, our y-coordinate is negative root 3 over 2. So then to get back and forth, we've got to add full rotations because they're not across from each other. And we need our argument to be equal to those. Our argument is theta over 2. So if I set theta over 2 equal to this one, 4 pi over 3 plus 2 pi n, and I set the argument theta over 2 to 5 pi over 3 plus 2 pi n, and now multiply both sides by 2, I get theta is, hit that with the 2, 8 pi over 3 plus 4 pi n. And this one over here, theta equals 10 pi over 3 plus 4 pi n. We could get common denominators. I'd have to multiply top and bottom here by 3. 10 pi plus 12 pi n over 3, that's theta. Or over here, top and bottom by 3 there, theta is 8 pi plus 12 pi n over 3. Two general solutions there. What was that one? 45? Okay. 51. Cosine theta negative 0.9. 51. Cosine theta is negative 0.9. We want just the answers on 0 to pi. So just looking between 0 to pi, including or? And it says to use a calculator. All right, so here's the way I would look at this. Cosine is your x-coordinate on the unit circle. It's wanting to know when the x-coordinate is negative 0.9. It's almost negative 1. That's going to be like right here and then right here. There's two angles, right there and right there. So because that's not a common value on our unit circle, the only thing we can do is take cosine of both sides. So if we take, sorry, our cosine of both sides. And this would give us theta, and this would give us something on our calculator. Let's see here. And I'm going to do this in radian mode. No, that's the wrong thing. All right, so here we go. I'm going to do arc cosine, and I'm in radian mode. Arc cosine of negative 0.9, and that equals 2.69 radians. I don't need to put that. Now I'm going to switch to degree mode and do the same thing. Oops, clear that. Arc cosine of negative 0.9, and I get 150, so I'm put or here, 154.2 degrees. So this angle, okay, this angle that it spit out was 154 degrees, which is actually that angle. I know it doesn't look like it. I kind of over-exaggerated this. It should actually be up a little bit more. I don't know, something like that. But the important thing is that at both those points, the x-coordinate is negative 0.9. So if this angle is spitting out is 154 degrees, the reason why it's giving me that and it's not giving me this one is because the inverse cosine function, the domain restrictions means you're only in the top two quadrants. The domain restriction is between 0 and pi. So it's only going to give me one answer back, and it's going to be 154.2 degrees. So if this is 154.2 degrees, how can we get this angle? Well, what we need to realize is that this distance right here is the same, or that angle, that measurement is the same as the angle measurement here. So what is that little piece? Well, it would be what I need to add to 154.2 to get to 180. So what would I need there? 25.8 degrees? This little piece right here is 25.8 degrees. Is that right? 26, what, 60? Yeah, that should be right. So that's 25.8 degrees. And that means that what I could do to figure out this angle is go all the way to here, that's 180, and then add the 26.8. So this is one answer. The other one is 180 degrees plus 25.8 degrees, which would be 205.8 degrees. Those are the answers. Wait a minute, hold on. 180, 154, 20, 205. Yeah, okay. So those are the two answers that are between 0 and 2 pi, because 2 pi is 360. But they want the answer in radians, not degrees. So what I could do is I could now say, look, how much is 2.69 radians? It's that much. Well, how much is all the way? I know it's 180 degrees, but how many radians is that? Well, that's pi, right? To go from here to here, it's pi. Pi is about 3.14. 3.14. So if you wanted to know how much that little angle is there, you would take 3.14, subtract 2.69, all right? Just to verify, this is 0.45 radians. So again, what I'm saying is this. I know that if I rotate out to here, this is 2.69 radians, and that's one of my answers. Now, if I go a little bit more, that right there is 0.45 radians. I know then that the other answer lives over here, and because of the symmetry, if I take 0.45 here, go by that much, I'll be at the second answer. But first I have to go and rotate through 180 first, or pi, and then add 0.45. So I'm really going to take this for my final answer, and I'm going to take pi, which is 3.14 approximately, and add to it 0.45, and get approximately 3.59 radians. So 3.59 radians and 2.69 radians are the only two solutions to that equation inside 0, 2 pi. That's a tricky problem. All right, let's try a different one. It'll be same sort of concept. 3 sine theta minus 2 equals 0. All right, so now number 57, that's what this is. Doing okay on time. Got a little bit more time, about 15 more minutes. See what I can get done here. All right, so I'll move the 2 over, divide by 3. So sine theta is 2/3. Now sine is the y coordinate. So where on the unit circle is my y coordinates 2/3? It's not a common value. So remember, this is 0, this is 1, 2/3 is about right there. It's going to happen here, in here. That's where the y coordinates are 2/3. So I have 2 solutions there. I don't know what they are, so I'm going to get those by using the calculator, doing arc sine on the left, arc sine on the right. Let's keep in mind though, when we do the arc sine right now, I'm only going to get answers out that are between negative pi over 2 and pi over 2. And that's just because arc sine's restrictions. So on my calculator, I should expect to see this answer, which I'm going to do it all in radians, all right? So hopefully you can follow this. So all in radians, I want to do arc sine of 2/3. And what I get is 0.72 radians. So the angle from here to here is 0.72 radians. Now I need to know what the angle from here to here is. So what I do is I say, well look, this right here should be the same measurement as this. So if we were to go all the way here across, that's pi, and then if I take away 0.72, that would give me this angle. So this angle should be pi, take away 0.72. So 3.14 minus 0.72 is 2.42. So my 2 answers are 2.42 radians and 0.72 radians. Man, got a lot to do here. Give me... Oh, I muted it. Sorry, I accidentally muted it. Just give me, I've got like 2-3 minutes. I'll be right back. I can't pause the video, then I create 2 videos, sorry. Number 59. Two cosine squared theta plus cosine theta is 0. All right, looks a lot like a quadratic. If we had replaced those cosines with u's, it would look like 2u squared plus u equals 0. And if you were asked to solve this, you would factor a u out, and then you would set each of these factors to 0. We're going to do the same thing. We're going to factor a cosine out, cosine theta. We're going to be left with 2 cosine theta plus 1 equals 0. And so now we can set each of these equal to 0. Now they do want the answers between 0 and 2 pi. So where is cosine theta equal to 0? And where is 2 cosine theta plus 1 equals 0? Solve this, move the 1 over, divide by 2. So you get negative 1/2. And this one we should be able to pop the answers off real quick because we're just looking between 0 and 2 pi. So where is cosine 0? So where is the x coordinate 0? That's here and here. That's pi over 2, 3 pi over 2. Okay, where's cosine theta negative 1/2? X coordinate negative 1/2 is here and here, those two angles. That's 2 pi over 3 and 4 pi over 3. That's it. 61, 2 sine squared theta minus sine theta minus 1 equals 0. Two sine squared theta minus sine theta minus 1 equals 0. Again, if we were to look at this like a quadratic, if we replaced the u with sine, it would look like 2 u squared minus u minus 1 equals 0. 3 terms here, we can't pull out a common factor like we just did. So we have to do the good old, whatever AC method, guess and check, whatever you're comfortable with. You should be able to factor that quadratic like that. And then at this point, just the u's are really signs. So this turns out to be 2 sine theta plus 1, and then sine theta minus 1 equals 0. Set each factor equal to 0. So when I set this to 0, I'm going to move the 1 over, divide by 2. I get negative 1/2. Here, when I move the 1 over, I just get sine theta as 1. So now we're looking on the unit circle. We're saying where's the y coordinate? Let's do this one, 1. That only happens here. So pi over 2. And then where is the y coordinate negative 1/2? That happens here and here. That's 7 pi over 6 and 11 pi over 6. Those are our only answers between 0 and 2 pi. '63. 63, they give you a trig equation. It's already factored. Tan theta minus 1 times secant theta minus 1 equals 0. So you just set these each equal to 0 because you already have it factored. So we want to know when tan theta is 1, just set that to 0 and solve. Set this one to 0 and solve. Secant theta is 1. Come on, what is that? Is that my phone ringing? No. I don't know how many emails I can get in one day. Okay, so now what we're doing is we're saying where's tangent theta 1? So where on the unit circle is the y coordinate divided by the x coordinate 1? We've done this before. That happens here. It happens here. Since I'm only looking between 0 and 2 pi, I know that's pi over 4, 5 pi over 4. Those are the two angles corresponding to those 2 points. Secant theta is 1 really means where's 1 over cosine theta 1? And if you multiply both sides by cosine theta, you wind up saying, well, when is cosine theta 1? Cosine's the x coordinate. That's going to happen here. So The other angle we have is 0. Now you could also say 2 pi, except for the fact that they only want the answer between 0 and 2 pi, not including 2 pi. Let me just double check that. Yeah, not including 2 pi. They put this, I believe. Your theta has to be bigger than or equal to 0 and less than 2 pi. So we do not include 2 pi in our solutions here. Man, something there. 67. I'm getting close to the end here. 67. Sine squared theta equals 6 parentheses cosine of negative theta. Now do they close that? Yeah, close that off, plus 1. Ooh, this looks nasty. All right. This should already throw you off, the fact that you got sines and cosines mixed together. But this is a negative theta is the argument. Here the argument is positive theta. So before I begin, what I'm going to do is use the even property of cosine and the fact that cosine theta is equal to cosine negative theta. We've talked about that in class. So I can just replace this with cosine theta, and it's still the same thing. Now, at this point, I'm going to distribute that 6 through. I'm also going to turn the left side into 1 minus cosine squared theta using the Pythagorean identity, because I'm going to try and get everything in terms of cosine. Now distribute the 6 through, like that. 6 here, 6 here. Now I'm going to move everything to one side. So why don't we move everything to the right side? So I'll have a 0 on the left side. I'm going to subtract 1 from 6, that gives me 5. I'm going to add this so it'll become positive. So cosine squared theta, I still have the plus 6 cosine theta, and then I have plus 5. And now that's starting to look a lot like a quadratic again. 0 equals, I should be able to factor this, cosine theta, and if I put 5 here and 1 here and plus, I should get it. Cosine squared, 5 cosines, 1 cosine, add those, you get 6. 1 times 5, that's 5. So that's it right there. Set each of these equal to 0. Cosine theta is -1, that's this one. This one right here, cosine theta is -5. Now, this one's saying where on the unit circle is the x-coordinate -1? That happens here. That's at pi. Here, this is saying where is the x-coordinate -5? That's outside the range. This can only be between -1 and 1, so there's no solution here. The only answer there is pi. 69 cosine theta equals negative sine of negative theta. Oh, okay. Cosine theta equals negative sine of negative theta. Ooh. All right. This looks weird. All right, so let's start with this. What is sine of negative theta? Sine of negative theta is actually equal to negative sine of theta. That's the even odd property. Sine is an odd function, so this is true. Now don't forget we have a negative out here already. So this becomes cosine theta equal, oh, and by the way, the reason I'm doing this is because this is theta, this is negative theta. I want everything in terms of theta. Same argument is what I'm looking for. So I had this negative here, but then this piece is going to turn into this. So negative sine theta. Negative is positive. So we're saying where is cosine theta equal to sine theta? Well, that means where is the x-coordinate on the unit circle equal to the y-coordinate on the unit circle? Where are they the same thing? And exactly the same thing. So that only happens here and here. That's where the x and y's match. This is where the x and y's match. So this is at pi over 4, 5 pi over 4. 71. Tangent theta equals 2 sine theta. Tangent theta equals 2 sine theta. Tangent theta equals 2 sine theta. Ooh, all right. So what is tangent? Tangent is sine theta over cosine theta. I want to know when that's equal to 2 sine theta. This is interesting. Interesting problem. How about now, I know maybe your instinct is to multiply both sides by cosine, but that's a little dangerous because what if cosine theta is 0? Then you're going to have an issue there. So instead, let's do this. Let's move everything over to one side. So all I did was move this to the left side so it becomes minus, and I still have this over here. Now notice this has a sine theta and this has a sine theta, so I can factor that out. If I pull a sine theta out, what will I be left with? So the sine theta out of here pulls the sine off the top, leaves a 1 up there. I have 1 over cosine theta minus, now I pulled this sine out, so I'm left with a 2, and then that's it, equals 0. This is a factor, set that to 0, sine theta is 0. The other one, 1 over cosine theta minus 2 is 0. We can work with this. 1 over cosine theta equals 2, that's moving the 2 to the other side. Multiply both sides by cosine, and divide both sides by 2. And you get cosine theta is a half. So this right here is saying where is the y coordinate? 0. That happens here and here. And so our answers are 0 and pi. And we're not going to include 2 pi because it's outside what they're telling us to look in. And then where's cosine? 1/2. Cosine's the x coordinate here and here. So this is going to be pi over 3. And then this last one right here is 5 pi over 3. Okay, those are the only 2 answers between 0 and 2 pi. And then these 2. So we have a total of 4 answers here. All right, I'm almost done. No, I'm not. But I'm running out of time. $73. I'm going to go fast. 1 plus sine theta, 2 cosine squared theta. 1 plus sine theta equals 2 cosine squared theta. Okay, moving quickly. I know I'm already moving quickly, but I want everything in terms of the same thing. So I'm going to decide to use the Pythagorean identity on the right side. Just be careful with that 2, because that 2 has to get distributed to both of these terms. If I turn this right here into 1 minus sine squared theta, the 2 has to go through. So I get 1 plus sine theta equals 2 minus 2 sine squared theta. Now I've got a nice quadratic. Move everything to the left. 2 sine squared theta plus sine theta. And then I had a 1 there and I subtract 2, so minus 1 equals 0.